measures. Okay, so LG equals 6x minus 14. NG equals negative 3x plus 22. Find the measure of G or find MG and find NG. Okay? Well, first of all, is this point in the middle? Is it our inline or is this our circumcenter, and why?
Circumcenter.
Why?
Because it's in the middle and all of the lines like go back to that point.
So remember, for a circumcenter, you have to have perpendicular bisectors. I agree, these lines, GN, GM, and LG, are all perpendicular, right? But are they bisectors of the sides? Do they split each side into halves? No. Where is G meeting? Is it meeting at angle bisectors or perpendicular bisectors? In line, or in center. That's where you have angle bisectors. Okay? Do you see how each of these, I'm gonna put them in red. These are all angle bisectors because they split the angles of each corner of the triangle in half. That's why this is our in-center. Okay? And for an in-center, guys, what you guys need to know is that each of these distances to each of the sides are equivalent. Okay? So GM equals GN equals GL by the in-center theorem. Okay? It tells us that LG or GL is 6x minus 14, and NG or GN is negative 3x plus 22. What do we do with those two values? What do we know about them?
Do you do 6x minus 14 equals negative 3x plus 22?
Good, because LG is this one, and NG is this one, right? And they're equal to each other, so we're just going to set those equal to each other. So it's going to be 6x minus 14 equals negative 3x plus 22, okay? You should have added 3x to both sides, added 14 to both sides. These would cancel, these will cancel, and you'll get 9x equals 36. Divide by 9, divide by 9. You get x equals 4. Now, it wants us to find MG and NG, okay? They're both going to be the same, okay? So all we need to do is plug it back into either one. Let's find NG. So NG was negative 3x plus 22. We plug back in x equals 4. We're going to get NG equals negative 3 times 4 plus 22. NG equals negative 12 plus 22, which should be positive 10. And then MG must also equal NG. MG equals NG. So we've got MG also equals 10. What's that?
Can you hold on this for a second?
Yeah, for sure. Good, Marcos.
Hold on.
Mhm.
Almost done.
Okay. For number 6, guys, is this the incenter or the circumcenter? G.
Circumcenter.
Why?
Because perpendicular bisectors.
Good. Each of these is a perpendicular bisector, okay? Now, it doesn't tell us that they're equal, like each of these sides are equal, like DK and JD. It doesn't show us that it's the middle, but does a circumcenter, or can an incenter ever be outside of the triangle? No. Incenter is always inside. Circumcenter is allowed to be outside, it's allowed to be on the triangle, it's allowed to be inside. So whenever you have one that's outside, it's never going to be your incenter, okay? So this one has to be your circumcenter. Okay? So let's go ahead and figure out. So this is one of them, this is another one, and this is another one, okay? So our equivalent lines are where we go from the circumcenter to our points of our triangle. So from G to J, from G to L, and from G to K. All of these are congruent, okay? So this one says that GL is 4x minus 2, GE is 3x plus 5, and GK is 2x plus 8. Which two are we going to set equal to each other? GL, GE, or GK?
GL and GE.
GL, which is this one. That one's congruent to GE.
Oh no, it's congruent to GK.
Good, GK. Do you see that? All right.
Yeah.
So GL equals GK. So we're just going to write 4x minus 2 equals 2x plus 8. We can subtract 2x from both sides. We get 2x minus 2 equals 8. Add 2, add 2. 2x equals 10. Divide by 2, divide by 2. X equals 5. GJ is just going to be equal to GL and GK. So GJ equals let's use GL. So GJ equals 4x minus 2. GJ equals 4 times 5 minus 2. GJ, equals 20 minus 2. GJ equals 18. So we found GJ. Now we need to find GE. All we're going to do, it told us that GE equals 3x plus 2, so we're going to plug it in there. But remember, GE does not have to be equal to GL and GK. So we were probably going to not get 18. Okay? So GE equals 3x plus 2. Plug in x equals 5. GE equals 3 times 5 plus 2. GE equals 15 plus 2. So GE equals 17. Yep. Guys, the most important part about yesterday's lesson is that you have to find some way, shape, or form to remember that incenters is the intersection of the angle bisectors, and your circumcenter is the intersection of your perpendicular bisectors. There's a lot going on in 6.2 and 6.3. It's not necessarily it's not necessarily that hard conceptually, but it's a lot to remember, okay? So if you don't understand what's going on right now, you need to go back over 6.2. Because what we do in 6.3 is just gonna get even harder, okay? If you're already lost, okay? So you need to go back to 6.2 and refresh your memory. Okay, this is the last lesson we're going to cover before our test on Wednesday. So tomorrow we're reviewing, Monday we're reviewing, and Tuesday we're reviewing. We have 3 days of review, and you guys have the entire weekend to study, okay? But we do have a test on Wednesday. Yes, Teresa.
I think on Canvas it says that the test includes 6.4.
Correct. I'm changing that. It's only going to be 6.1 to 6.3, okay?
Okay.
The reason we're not including 6.4 is there's so much information in these 3 lessons that it's basically the middle of the chapter. And then we've got 3 lessons afterwards, and then you'll be tested on those as well.
Okay.
I will update Canvas so it doesn't show 6.4. Hopefully today. I'll update Canvas today. It should only be 6.1 to 6.3. All right, guys, let's do this. Chapter 6, Section 3, medians and altitudes of triangles, okay? So we're learning two new vocab words, your medians and your altitudes of triangles. A median of a triangle. So a median of a triangle is a segment from a vertex to the midpoint of the opposite side. So what that means is our bisector or our midpoint, okay, is right here. So this is the midpoint on D. And it goes to the vertex on the opposite side. Okay? Let's take a point here. And let's call it E. Where should E go to in order to be a median? What point do you... To D?
Or, yeah, D.
Mm.
Or like in between D and C.
In between D and C? Yes. All the way to B. Do you see how B is the point opposite that side? The vertex opposite that side? This is our median, okay? From E to B. And it should cut A and C into 2 equal parts, okay? What about here? If we took this point and called it F. F to what will be a median? A, very good. Okay? F to A. And what 2 line segments are going to be congruent on CB?
CF and FB.
Perfect.
CF.
Yep. CF and FB. Beautiful. Okay? That is the definition of a median. It goes from the midpoint of one side to the vertex of the opposite side. Every triangle has 3 medians, and the medians are concurrent. Okay. When those 3 medians meet up, the point of concurrency of the triangles, or of the triangle, is the centroid. Okay, so another vocab word. The centroid, just like the incenter, is always inside the triangle. Okay, just like the inside of the centroid is always the inside of the triangle. The cool thing about the centroid is it's called the center of gravity. Because if you were to take like a pencil, right, and you were to stick that triangle on top of that pencil, that's the center of gravity. It would balance perfectly, okay? It's where you have the most balance on a triangle, okay? Go ahead and up at the top of your page, I want you to write perpendicular bisector. Means circumcenter. That could be in, on, or outside your triangle. And then go ahead and write angle bisector. That could be, and that's going to be your in-center. And that will always be inside. Okay? So we just added another one. It's called the centroid, right? And you find it by connecting all the medians. And it's always going to be inside. Okay? So if you wanted to add to this, you would put medians. That's your centroid. And it's always inside as well. So we've got circumcenter, in-center, and centroid. Circumcenter is where the perpendicular bisectors meet. In-center is where the angle bisectors meet. And centroid is where the medians meet. Yep. Okay. Now, the thing that you guys need to know on why a centroid is important is that the centroid of a triangle is 2/3 the distance from each vertex to the midpoint of the opposite side. So the medians of triangle ABC meet at point P. And so AP is 2/3 of AE, BP is 2/3 of BF, and CP is 2/3 of CD. So what we're going to do to remember this, okay, is we're going to fill in which portions are 2/3 and which portions are 1/3. So from the vertex to the centroid, that's going to be 2/3 of your whole length. So from B to P, this will be 2/3. This will be 2/3. From P to F, this will be 1/3 of the length, okay? From A to P, this will be 2/3. From the vertex to the middle, or the centroid, from P to E, this will be 1/3. From P to C, this will be 2/3. And from P to D, this will be 1/3. Okay? This is the only one, guys, where segments are not congruent. Where segments are not equal. So in an in-center and in a circumcenter, you guys always will have congruent lengths, right? The centroid is the only one where the segments are not going to be congruent. Okay, so in LMN, S is the centroid, RL equals 21, and SQ equals 4. Find LS. Okay, so S is the centroid, so let's just put a dot at S. And it tells us that RL is 21. So this whole distance right here, from R to L, is 21. Okay? It also says that SQ, which is this short distance right here, is going to be 4. Okay? And it wants us to find LS for A. So for A, LS is this distance right here. okay? That is the distance from the centroid to a vertice, L, right? So it's going to be 2/3 whatever RL is. So LS equals 2/3 times SL. I'm sorry, yes. No, not SL, RL. It's going to be 2/3 the whole length, okay? That'll be 2/3. RS would be 1/3 the length of RL, okay? So we take 2/3 of RL, we've got LS equals 2/3 times, and we know RL is 21. So LS equals 2/3 times 21. Well, we can just do 2 times 21/3. This is going to give us 42 divided by 3, which should be 14.
What does that say that you wrote for the triangle?
Where?
Not before, the one on top in triangle and SR.
21.
Like not the. Oh, okay.
It's a 21, and then it's just like a little squiggly showing that the full length of that side from R to L. Okay? Okay, so the next portion, okay, we want to find NQ. NQ is that whole median, okay? It's this whole median right here. In order to find NQ, okay, so B, NQ equals, and it's going to be 1/3, or SQ, I'm sorry, SQ is going to be 1/3 the distance of NQ. Why? Because it's the shorter side. It goes from the point to the middle of the side. It's the second part of the median. It does not go to the vertex from N to S. It goes to the side. So that's going to be 1/3 whatever the full length of NQ is. Okay? So what we do here is we plug in SQ, which is 4. So we have 1/3 times NQ equals 4. All we need to do is just multiply both sides by 3 to get rid of that 1/3. And we're going to get NQ equals 12. Okay, guys. I'm going to write both the equations for MP. So MP is also a median, right? It goes from the middle of a side to a vertex, the opposite vertex. Okay? So point S divides it into 2/3 and 1/3. Okay? So MS is going to be 2/3 of MP, the whole length. Okay? And then that second 1/3 is going to be SP. So SP will be equal to 1/3 times MP, the whole length. So if you combine those, 2/3 and 1/3, you'll get the full distance, which is just 1 MP. That's just an example, okay? To help you guys see it a little bit better. Okay. A sculptor is shaping a triangle piece of iron that will balance on the point of a cone. At what coordinates will the triangular region balance? So remember, when we're talking about balance, we're talking about the centroid. Okay? We're talking about the centroid whenever a question's asking about balance. And how we're going to find this is we're just going to find the midpoint, and we're going to connect each of our medians and see where they intersect, okay? So we're going to find the midpoint of each side. So let's go ahead and find the midpoint of this first side. I'll highlight it in blue. And I'll label it the blue side. Okay, the blue side midpoint, we're going to add the x's together. So 6 plus 10 divided by 2. And we're going to add the y coordinates together. So 6 plus 7 divided by 2. Okay, this will give me 16 divided by 2, which is just 8. And then 6 plus 7 is going to be 13 divided by 2. I'm just going to leave it as 13 over 2. Okay.
Alright, that's your bell.
Oh, is it? Okay.
It's 11:10.
Guys, I will finish these notes tomorrow. Please turn in what we got to today. I did not realize that was the bell. We graphed this triangle, and then we were finding the midpoint of each of the medians. So the midpoint that we first found was 8, 13 over 2, which, guys, is just the same as 8, 13 over 2 is 6.5. Yeah, what's up, Teresa?
I don't know if it's just on my screen, but it says like your name and then has started screen sharing and it won't like go away, so it's like blocking the slide.
What about now? Does it work now?
For me it does. No.
Juliana, does it work?
Yeah.
Okay, cool. Okay, so 8, 6.5. All right, so let's just find that point. So let's move over 8 units and up 6.5, and that's going to be right here. So that lies on our line, looks about in the middle, so we're good. Which one is it going to, are we going to draw a line from that point to 8.2, 10.7, or 6.6?
8-2.
8.2, very good. Because the median goes along the triangle to the opposite vertex. So that's our first median. All right, next, let's do what we're going to call the red side. So let's highlight from 6.6 to 8.2 in red. We'll call that the red side. And we're going to find our midpoint. So red side, midpoint. Okay? How do we find the midpoint?
X2 minus X1 over 2.
Close.
No, plus.
Plus. There we go. There we go. So what are my x coordinates?
For the red, 6 and 8.
Good. 6 and 8. So we add 6 and 8 and we divide by 2. What else do I do for the midpoint?
Y2 minus plus Y1.
Mm-hmm. Good. So what am I adding?
6 plus 2.
6 plus 2. Very good, Teresa. What's my midpoint?
Hold on.
14 over 2 and then 8 over 2, right? Which is
7 over 4.
7 comma 4.
4, 4.
Good. So let's find 7, 4. Here's 7 units, up 4. Beautiful. Where are we drawing our line to?
10, 7.
10, 7. Very good. Okay, we're drawing it across the triangle to 10, 7. Oops. Can we kind of see where they're going to intersect?
Yeah.
Okay, at 8, 5. Very good. Now, just for insurance, let's do the last one too. Okay, so let's highlight that last side, and we'll call it, let's do it in green. And let's call that the green side. How do we find the midpoint of the green side?
10 plus 8 over 2. And then 7 plus 2 over 2.
Good. What are we going to get?
18 over 2 and 9 over 2.
Mm-hmm. I think this is 9 and then 9 over 2. Let's not leave it as 9 over 2. Let's put it as a decimal, so like 4.5. Yeah. So let's find 9 in the x direction and go up 4.5 units. Where are we drawing that line to?
6, 6.
Good. Between 6, 6 and that midpoint. See how they all intersect at the same point? If they didn't, guys, we probably calculated a midpoint wrong. Okay? And just like Samantha said, this point right here is 8, 5. And what do we call that point? There's a few names that we've learned. It's either the circumcenter, the in-center, or the centroid. It's the centroid. See how this can be confusing, guys? You need to know each of them, okay? And we're learning one more today. So we've learned about centroid, we've learned about circumcenter, we've learned about in-center. We're also going to learn about one more point. It's called the orthocenter. And that's all you need to know for your test, those 4. Plus what a perpendicular bisector is, then an angle bisector. But though, if you didn't know what an angle bisector or a perpendicular bisector was, you couldn't figure out what circumcenter or in-center were, okay? All right. Altitude of a triangle. An altitude of a triangle is the perpendicular segment from a vertex to the line containing the opposite side. Every triangle has 3 altitudes. An altitude can be inside, outside, or on the triangle. So altitude, like, have you guys ever calculated like the area of a triangle?
Yeah.
You know how sometimes they use like the word, or like the length, the height?
Yeah.
It's just the height. The altitude is just your height, okay? So it's however tall your triangle is. Now, depending on which way you're looking at it, the altitude could change, right? So you could look at the triangle as like, these examples, we have PR as our base, right? What if we changed it and we made QR our base? So if you can like flip your iPad screen so that QR is now your base. So like kind of turn it to the side and go ahead and locate point P and just draw as straight of a line as you can that's perpendicular to QR. So straight down. Should look something like that. And then just draw that nice little right angle mark. Okay, we're gonna do the same thing, but now make QP your base. So flip your iPad. So now QP is your base. Find the point R, which is on the opposite side, and then just draw a right angle down there. So every single triangle has 3 altitudes, okay? It can be inside, outside, or on the triangle. Okay, let's do the same thing for QPR, but the one on the right. So PR was our base, and we found that Q was that altitude over there on the left, the red one. Flip your iPad so that QR is your base. Turn your iPad so QR is your base. Find point P and draw that 90-degree line, that perpendicular line to QR. Should look like that. But extend it. Okay? Okay. Next, make QP your base. Find R, and then draw a perpendicular line to QP, as if QP was extended. Do we see where these three altitudes are going to intersect? Somewhere down here, right? Why do you think they intersected outside the triangle? Because it's obtuse, okay? So remember those rules that we had about the circumcenter? Do you guys remember those rules we had about the circumcenter? Those also apply to when we're finding the point where the altitudes intersect, okay? All right, so this next slide is called the orthocenter, okay? And your orthocenter is where all three of the altitudes meet up, okay? It's the point of concurrency. Now, what the orthocenter doesn't give you is any information, okay? It doesn't tell you anything about congruent segments, nothing like that. All it tells you is where the orthocenter is, okay? So this is probably the easiest one of the four, because you're not going to have questions. It's like literally if I were to quiz you or test you on this kind of stuff, it would just be like, okay, where is the orthocenter? That's about all I can ask, because there's no information you can gather from the orthocenter. Got it? Okay, so that's our example, is we're going to find the orthocenter. Okay, so we're going to find the orthocenter of x, y, z with vertices x at -3, 4, y at -3, 4, or I'm sorry, x is at -3, -4, and z at 5, 4.
Oh, it's -3, 4. You mixed y up with x.
Okay, we'll figure it out. So x is at -3, 4, so we go to the left 3 and down 4. Boom, this is x. Y is at -3, +4. That's y. And z is at 5, 4. What kind of triangle do we have? A right triangle, okay? Now, remember, the same rules that apply to the circumcenter apply to the orthocenter. So where do you think our orthocenter is going to lie? On the triangle. Very good, okay? Give me 1 second here, guys. I got an email. Okay, so all we're going to do here, guys, is we're going to find the height using each of these sides as our base. So first, flip your iPad so XY is your base. Go from Z and make a 90-degree angle with XY. What line are we going to draw?
A line down the middle.
A line just like this, along YZ, okay? So that's one of our altitudes. Oops, not with the highlighter. Choosing red. Okay, next, flip your iPad so that YZ is now your base. And by base, I mean it's at the bottom, right? What's our altitude? It's just going to be from X along XY. And lastly, flip your iPad so that XZ becomes our base. Start at the opposite vertex and just draw a 90-degree angle down. Where did these all meet? Where do all of these lines meet up?
Y.
Yeah, very good, Y. Good, at -3, 4. So Y is just our orthocenter. So our orthocenter is that on our triangle? Yep,
Yes.
because y is part of our triangle. Very good, okay? So remember, right triangles, it's going to be on, acute, it's going to be inside, and then obtuse, it's going to be where? Outside. Okay, this next slide, guys, is very useful.
Yes.
Okay, guys, I need you guys to do one thing. So we are going to play a gim kit about this, but I need you to do the gim kit a certain way. I need you to go to DE. I need you to go to yesterday's notes assignment. Okay, and then where are my classes? There's going to be a link there in a second. There we go. Okay, refresh yesterday's notes assignment in the details section, and you should see DE and then a link for GimKit. I need you to click on that link. So in yesterday's assignment, so lesson 6.3 notes from 2.4, February 4th, I need you to click on the DE link. Once you click on it, it'll take you to GimKit. You're gonna set it up with your Gmail. Set it up with your McCarthy Gmail. And then you're gonna join my GimKit. The reason I'm having you do this is because now I've started a class for you guys, and then I can give you guys like GimKits via the class. It'll just be a lot easier. And then it like tallies like your score based on like the season and stuff. No. Did my thing expire? No. Ugh. Hold on, guys. I'm paying for GimKit now. Okay, we're gonna play hidden mode. And we'll play for 8 minutes. Here's the code, peeps. Make sure you clicked on that link, otherwise it won't. Oh, hold on. Nope, don't join that one. Don't join that one. Sorry. Okay. Hidden mode. Period. DE.
When I click join game, it like just nothing
is this
pops
Lucia?
up. Like I didn't click the
She
link.
is, but after this class.
Oh, okay. Thank you.
Okay. What's that, Teresa?
And I'm clicking join game from the link. It's just taking me to like a blank screen, like without anything on it. Like
That's fine. So that means that you already logged in. You logged in, right? Or you created an account?
yeah.
Okay, so now just go to gimkit.com/live, this URL up here, and then just type in the game code.
Oh, okay. Because I was still doing it through the link.
Okay, guys, remember okay, the location of the OrthoCenter depends on the type of triangle. Sometimes I would say the OrthoCenter is probably one of the toughest to visualize, okay? My recommendation is whenever you guys are given something, just keep flipping your iPad, or where, like if you copy down the image on your paper, just flip your paper so that you change where the base is, and it's much easier to see. It's hard to do if you're just gonna like look at it straight up and down and be like, okay, here's the altitude, here's the other altitude, here's the third altitude. For me, that's hard. If you can visually see it just by looking at it straight up and down, like all the power to you, okay? But I like to rotate my images. All right, so that's where an obtuse triangle meets up, that's where a right triangle meets up, and that's where an acute triangle meets up, okay? OrthoCenter. And our last slide is our concept summary. So we've learned about 4 different types of points: the circumcenter, the incenter, the centroid, and the orthocenter. This will be your best friend working on reviews and homeworks, okay? This is like a mini cheat sheet. What's up?
Is the test open notes?
Yes. So you can print this slide. This is a very good slide to print, because remember, you can use handwritten notes. Or you can just write down what's important to you from this slide.
Okay.
All right? The test will be open notes. But those notes need to be printed, right? Because we're going to be in lockdown. Okay.
The review pages on Canvas that you're talking about.
You don't see the review pages on Canvas?
No. Are they like, are they supposed
Wait,
to
so
be
you can
on
submit
the
this
to-do
now?
list?
They should be.
Submission?
Hold on, let me check. Oh, that's why.
Can we go ahead and submit this?
Yeah, you can submit the notes now.
Okay.
Submit them to yesterday's notes though, right? 2.4. Yeah, Reynold, I can go back. Do you see them now, Teresa, if you refresh?